We're in a really cool place. Grand Canyon is probably the top bucket list item for every geologist. And I've had the privilege to study here for many years, both from the rim and now from the river as well. And one of the things I've been studying for 25 years is this sandstone right here. So we haven't talked a lot about the layers that are coming down through the canyon yet, but up on top we have the Kaibab limestone. Down below that, kind of in the middle of this cliff behind us, we have the Torowheat Formation. And then right down here at river level, we're seeing what's called the Coconino Sandstone. And you might notice that the Coconino is a little bit different than some of the other layers, in that it has these angled layers in it. And these angled layers are called crossbeds. And you might notice even across the river, you look up higher and the rocks do not have crossbeds in them. They're nice and flat. And so this sandstone's a little bit different. This sandstone was first studied by Edwin McKee in the early 1930s. He published a paper on it in 1934 as a young geologist, and he looked at the Coconino in a number of places in the Grand Canyon and came to the conclusion in that paper and in subsequent papers throughout his lifetime that this sandstone was made in a desert. And so here's what his thinking was these crossbeds are really big crossbeds, really thick sets. And one of the places that geologists can see crossbeds forming in the world today is in big desert sand dunes. And so that was McKee's thinking, and the thinking of a lot of subsequent geologists, that this formation was made in a desert. Okay? And so that's a bit of a problem for us as creationists. Why would that be a problem? Yeah, we can't have a desert in the middle of Noah's flood, can we? And so I and a number of other geologists began to study the sandstone here in the Grand Canyon and some other places in Arizona. And we found some really exciting things in here that a lot of geologists have missed. A lot of geologists have, pretty much went on Edwin McKee's word that this is a desert sand dune deposit and haven't looked into it very much. And that's kind of surprising. That was the 1930s. And, here we are almost 90 years later. And, a lot of secular geologists haven't looked into this further. And so I didn't know what we were going to find. But as Ray Strom and Paul Garner and I and a few others started to look into the sandstone, we found some really interesting things. First of all, Edwin McKee said that these crossbeds are really steeply dipping, that the angle in here is really high. And so I'll ask you guys, what do you think the angle is here?
8 degrees, 30 degrees.
30? We got 8. Any other guesses? 20? What do you think? Any other guesses here?
10.
So 10. So we're looking at this angle right in here. Well, geologists have a special device that they can use to measure crossbed angles. It's called the Brunton compass, and that is quickly being replaced with the iPhone, right? So I can put my iPhone on this surface right here, and I can measure what's called a strike and dip. And so if I put this on here, I can look at this second number over here, and it tells me what the angle of dip is and what the direction of dip is. And somebody want to come up here and tell everybody what it is? Come on up here. You can. One of you guys, come on. Yeah. All right. So tell everybody what that second number is right there. 19, and then there's a letter after that. S, that stands for south. So 19 degrees south. So that's what the angle is right there. And guess what the angles in deserts are? Oftentimes the angles in desert sand dunes are right around 30 degrees or even higher. I've done a lot of work looking at those angles, and it looks like about 20% of all the crossbed dips in desert dunes are 30 degrees or higher. And guess what? I've measured a lot of crossbed dips in the Coconino, and guess how many crossbed dips of the hundreds that I've measured, guess how many are greater than 30 degrees?
0.
I think I maybe found one or two. That's it. But, you know, in desert dunes, 20% of them are really high. And then also in desert dunes, there's a number of crossbed dips that are really low. And what's really interesting about the Coconino is the crossbed dips tend to range. Most of the dips fall, if you do the statistics on them, between about 15 and about 23, 24 degrees, somewhere around in there. And they all tend to bunch in there. Where deserts, you get a big spread of crossbed dips across the whole spectrum. So that was one of the things that right away we're thinking, that's not quite right. And so the other thing we started to do is look at the rock under a microscope. And when you look at desert sand under the microscope, desert sand tends to be round, like a ball. And that's because the desert sand grains come and hit each other, and it knocks all the corners off, and they tend to get round. And when you have desert sand, it tends to be all about the same size. And so one of the things we started to do is collect rock samples. And here in the canyon, you have to have a permit to collect any type of rock samples. So don't collect rocks while you're here. None of you have a permit to do that. But we had permission to collect some samples in various places and started looking at this rock under the microscope. We went other places around Arizona and started to look at the rock under the microscope. And one of the things we noticed right away is that these sand grains aren't round. They're angular. And we're like, that doesn't make a whole lot of sense. And if this is a desert deposit, that doesn't make sense. And we noticed that there were a lot of different grain sizes in the rock. And so that doesn't make sense with the desert either. And so we're beginning to put some things together. How do we explain this? Well, the best way to explain things like this is deposition underwater. And since those early studies, some of the very first things that we noticed there, we've noticed some other things too. As we looked under the microscope, that we saw a mineral called mica under the microscope. And you could probably look at the sand right here in the sun and see little shiny spots in the sand, and those are muscovite flakes. It's a type of a silver kind of mica. And guess what? When you go to deserts, you don't find any of that mica in there because it's really soft. It's about as hard as your fingernails, and when that mica blows around in the deserts, it gets all chewed up, and so you don't find mica in the deserts like that. We found other minerals. We found a mineral called dolomite, and dolomite is a marine mineral. It only forms in marine settings and so on. And we found dolomite beds. We found little dolomite ooids. Those are like little balls. We found dolomite cements and other types of dolomite in there, and not just in one place, but a lot of different places. And so things like that tell us that that this rock is not formed in a desert environment, but that it's formed underwater. One of the most exciting things we found was down in Sedona. And let me grab a piece of paper here. So down in Sedona, the Coconino is down there as well, and we have crossbeds like this. But we found some of the crossbeds are flipped over like this into a sideways U. Now some of you have had geometry. What is a U-shaped structure like this called? You can draw graphs and stuff like that of these. They're called parabolas, right? So we found some folds in the Coconino where the crossbeds are actually folded over like this into these sideways parabolas, and they're called recumbent folds, parabolic recumbent folds. And guess what? Parabolic recumbent folds only can form underwater. You need a strong current that's moving really fast, and that's how crossbeds form, is under strong currents. There's crossbeds in the bottom of the Colorado River out here. But you get crossbeds to form, and if you have a really strong current, sometimes the crossbeds can flip over and make these U-shaped parabolas called parabolic recumbent folds. And those are down in Sedona, and we found them in a few other places as well. But you look at all of this data together, and what does that tell you about Coconino Sandstone? It has things that we can't explain in a desert environment. It has features that we would never find in a desert, but it has lots of features that we would find in the ocean or we'd find underwater. And so one of the things that I've done is I've gone to secular conferences and published literature in the secular journal as well as creation journals arguing for the underwater deposition of this sandstone. And I've had some really interesting responses. One year I was at a geology conference and I had some pictures of these really nice folds up on the poster. And a guy came by and he didn't even look at the title of the poster. He just recognized that these were classic parabolic recumbent folds. And he came up and said, "Oh, aren't those things so cool? Those are so neat how they form." And I mean, he immediately visually recognized that they were parabolic recumbent folds. But then he looked at the title of the poster and said, "Coconino Sandstone. Oh, wait a minute, those can't be parabolic recumbent folds." And I'm like, no, they are. It's showing that the Coconino was not made in a desert like everybody thinks it was. And so I guess the lesson that I and a lot of other people have learned is we do need to do the science. We need to dig into the science. We need to look at the rocks very carefully. But we shouldn't be afraid as Christians. I think I was a little hesitant when I started the Coconino project because I knew of all the stuff that was out there that had been published on it and so forth. And, it really didn't look good. But when we started digging into the literature and actually seeing what was there, we were surprised. And, the information that we found, I think, confirms very nicely that this was made underwater. And it, takes one of these things, takes one of these arguments away from the evolutionists. The evolutionists use things like the Coconino and the Navajo and say, this proves that the Bible is wrong. And we can say, hold on, just a minute. Let's look at this, and look at all these features. No, this sandstone actually supports what we read in Scripture about the Genesis flood. So, a few questions. We won't spend long here, but a few questions. Yeah.
Just curious, when you're comparing wind forms versus subterranean, what are the angles that you find subterranean?
The average in both settings tends to be 20 degrees. The difference is in the spread of the angles. So in deserts, the spread of the angles is all from just a few degrees all the way up to about 40 degrees. And they're kind of evenly spread through that whole range. So you find lots of low angles, lots of high angles, lots of stuff in the middle. In the Coconino, they all tend to be grouped right around 20 degrees with an average of 20 degrees, but they're grouped within about 4 or 5 degrees of that middle point. So I think that's an important distinction that we can make. It's not the crossbed angle itself, but it's the distribution of the angles that's important. If that makes sense. Yeah.
This almost looks like, and I know this isn't correct, but this looks almost like subduction plates when you look at it. I'm sure that's way off.
Yeah, so it's not subduction. These angles are just what we call crossbeds. And a crossbed forms, and you guys can actually play in camp with this, but a crossbed forms as sand gets pushed up one side of a slope and then kind of avalanches down the other. And you guys will be sitting in chairs around the camp and play with your feet and make little avalanches and stuff with your feet. And the sand is going to avalanche at something called the angle of repose. That's about 33 degrees. And it's true under air, it's true under water, but these are not angle of repose dunes, as a lot of people have incorrectly argued. We measured it. It's 19 degrees. Okay, so this is not angle of repose. And a lot of geologists have been fooled by that. They go and look at crossbeds. I've done the same thing in the Navajo sandstone, which is a sandstone that has even thicker sets of crossbeds in it. And I think because the crossbed sets are so thick, people get tricked into thinking that the angles are steep. But you go measure the angles and guess what? They're the same as what you find in the Coconino. We're going to get downriver a couple days and see the Tapeats sandstone. It's all the way down at the bottom of this stack of rock. And the Tapeats has just little thin sets of crossbeds in it. But guess what? I've measured all the angles in there, and guess what the average angle is? 20 degrees. And so people can get tricked really easily, and that's why it's important to actually go out and make the measurements. So, yeah.
You were saying the sand you find in the desert is actually round.
Mm-hmm.
The stone is made up of round granules?
Well, this sand right here and most other sand is primarily made of quartz, the mineral quartz. And as it runs into each other in the desert setting, it tends to get all those angles chipped off. And so, especially in the bigger grains. Smaller grains, not so much, but the bigger grains, it gets all the edges chipped off. But when you have river sand or beach sand or sand in the ocean floor, it's angular. And the reason it's angular, because as the sand gets carried along and collides with itself underwater, the water is cushioning those collisions, and you don't get the edges chipped off.
So it doesn't ever resettle and become rock again?
Yeah, it can resettle and become rock.
Is that made up of the round
Yep.
granules also?
Yep.
Wow.
Yep.
Interesting.
Yeah. So, all right, there's one more thing that we're going to look at in the Coconino that's really interesting. We're going to stop at a place downstream called Soap Rapid, just before Soap Rapid. And one of the interesting things in this sandstone, there's little footprints in it. And the footprints are one more evidence that this was made underwater. So we'll talk about that a little bit more when we get to that section. But when we stop at the Soap Rapid to look at the footprints, you want your camera with you, because those little footprints are just so cool, and they're in the crossbeds of this rock. So the animals actually crawled up the crossbed slopes. We don't find any of them going down the crossbed slopes. All their toes are always pointing
Trying to get away from the
up. So we'll talk about that. Really interesting spot.